The purpose of this experiment is to evaluate the cold working effects on the mechanical properties of steel. Before starting this experiment, use safety glasses. The material and tools used in this experiment are bicycle spoke, UTF tester, knife edge extensometer, and furnace. The theory used in this experiment is annealing. The steel is heated over 38 Celsius and then placed to cool. This method increases the steel's toughness and relieves stress. Cold working will cause deformation when the temperature is below recrystallization. Cold working will increase the strength and it'll give the steel a higher quality finish.
Cut the bends of the bicycle spoke and cut it in half. Wear safety gloves and use the tongs to place the sample inside the furnace. Now we will set the temperature to 950 degrees Celsius and we will wait for 30 minutes. After 30 minutes, remove the sample and place it on the plate. Now we can see that the sample has been transformed. Note the dimensions of the sample after taking it out from the furnace.
Turn on the UTS machine, run data, and select Tensile properties of round bar. Insert the group's information and the sample data. Enable YAS and load the sample inside. After the sample has been loaded, make sure to lock it tight.
Mark 2-inch gap on the sample with a marker so that we can fit the extensometer. Then use the extensometer and groove the sample where that marks are located. On the computer screen, zero the force and extension and click Test. Now click OK for the two dialog boxes shown at the screen. Now we have to wait until it asks for the extensometer to be removed.
Hi, this is Harwinder Sandhu, and I would like to explain you about further. First, remove the extensometer and press OK, and wait for a sample to break. After it has broken, save and remove the sample. Using the caliper, measure the extension.
Repeat the datum steps for the next sample. After the sample has been tested, view the graphs. Save the two graphs and compare them.
Hey, my name is Suveer Singh. I will be comparing the two force versus extension graphs of cold work steel against annealed steel. So our first specimen is the normalized or annealed steel sample. If you observe the graph, it has the force plotted as the y-axis and the extension as the x-axis. Notice that the force is plotted in pounds and the extension as percentage. Since normalized steel has superior toughness than cold work steel, you can observe a yield strength of around 422 pounds, which is comparatively higher than the cold work steel. A 0.2% offset from the original curve in the x-axis direction gives us the exact location of the yield point of the specimen, which is basically the intersection of the pink line and the blue curve. Beyond the yield point, the specimen is no longer elastic and begins to flow in a plastic manner. It becomes plastic in nature. Other properties relating to the curve can also be seen in this graph, such as the yield strength, the tensile strength, and the total elongation, which is 1.5%. Now for our second sample, which is the cold work steel sample. Again, its graph has been plotted using the force applied in pounds as the y-axis and the extension in percentage as the x-axis. Um, since cold work steel has inferior toughness than normalized steel, you can observe a yield strength of around 302 pounds, which is comparatively much lesser than the normalized steel sample. Again, a 0.2% offset from the original curve in the positive x-axis direction gives us the exact location of the yield point of the specimen, which is again the intersection of the pink line and the blue curve. Beyond this point, the specimen becomes plastic in nature. Other properties relating to the graph can also be observed, such as the yield strength, the tensile strength, and the total elongation.